Okay, the carpenter wants to make a coffee table in the shape of an equilateral triangle. I'm just going to go ahead and sketch kind of what we're looking for here. It says that she doesn't have a way to measure 60 degrees, but she can measure a right angle and the length. So she must have the tools for that. She wants the perimeter to be 9 feet, which means that each of these are going to be 3 feet. How should she design the table? Okay, so I'm just going to review some things that I think you already know. This is 60 degrees, this is 60 degrees, and this is 60 degrees. Now, are you aware that if you drop an altitude down, then you know that that's equal to, it creates a right angle for one thing, and then it also will bisect this base because this was an equilateral triangle. It was an isosceles triangle, actually, also an equilateral triangle. So the idea here is that if you can drop a right angle down and you know this dimension, then you could double it for that side opposite the right angle. So we're going to kind of be working backwards here to help her out here because she doesn't have an equilateral triangle to start out with. All she knows is that each dimension is going to be 3 feet. So let's just kind of start here with a 3-foot piece, right? Okay, so let's just say she knows this is 3 feet long. Okay, so we got this is 3 feet. Now notice that I'm going to say that kind of correlates to maybe this piece right here. So we know she can make a right angle. All right. So if she can make a right angle, maybe we should correlate it to this piece right here. But that's going to be a little hard to do as well. So let's just draw a right angle from here. Okay. So we know she knows she can draw a right angle there. Okay. Now if we think through this, now that she has her right angle, it looks like the right angle needs to be up against her base. So if she knows this is the right angle here, technically then what she needs to do is make this dimension 1.5. Okay, so she knows this is 1.5. That means she can come out this way 1.5 as well. Okay, so if she knows that, and she can measure length, right? So if she knows this is 1.5, she can also figure out, using the Pythagorean theorem, that what this height should be. So if she's got 1.5 squared plus x squared equals 9, because it's 3 squared, so she can say x squared is equal to 7.5, so we know that x is going to be the square root of 7.5. So the square root of 7.5 is equal to about 2.74. So 2.74, okay? So what you could recommend to her is that she makes sure that this is 2.74 units tall. And if she's got that exact, and she knows this is 1.5 and this is 1.5, then she can just connect the segments like this, and she'll know she has a right triangle. So if she wants the table to have a perimeter of 9 feet, how should she design the table? First thing she needs to do is create a right angle from one of her sides. Okay, that's going to be step 1. Step 2 is determine the altitude using the Pythagorean theorem. Okay? Once she has her altitude, she should connect the top of the altitude. In this case, the top is right here. Okay? Connect the top of the altitude with the endpoints of the base, which is 3 feet long. Okay? making sure that the altitude is centered on the base. What I mean by that is that this altitude here needs to be centered on the base. So when she draws this altitude, she needs to make sure she has 1.5 this direction and 1.5 this direction, and then she's got her height. When she connects these guys, they'll all be congruent to one another.